When you take a 30, 60, 90 triangle, what this winds up being is half of what type of triangle? If we put two of these back to back, we create what? 60, 60, 60 becomes a equilateral triangle. So the reason 30, 60, 90 winds up being a special triangle, it's half of an equilateral triangle. And there's several pieces to consider. What we're going to do as our reference point is we're going to start with the side or the leg opposite 30 degrees. If we assign that the length of x, what does that mean the length of each side of this whole equilateral triangle is going to be? 2x. So what we can do is we can label our hypotenuse 2x. So right now, just by looking at that as half of an equilateral triangle, we're able to find two pieces of this pattern. The leg opposite 30 degrees is x. The hypotenuse will be double that. Okay, so I want you to use Pythagorean theorem and see what would the side opposite 60 degrees be based on Pythagorean theorem if a leg was x and hypotenuse was 2x. And so just take a moment, see if you can calculate the formula equation form of the side opposite 60 degrees. I'm going to call this b here. So we have x squared plus b squared is equal to the quantity 2x squared. So if we're solving for b squared here, we can square the 2, square the x, isolate the b term. So we're going to subtract an x squared from both sides, extract your square root. We get b is equal to the square root of 3 stays as it is. The square root of x squared can be reduced to x. So we get x root 3 to be our third side in that. And so these are your patterns for 30, 60, 90. It's x, the side opposite 30 degrees. X root 3 is the side opposite 60 degrees. And then 2x is the hypotenuse. Anytime I refer to this, I'm going to do one of two things. I'll either refer to it by the angle it's opposite. Okay, so x is the side or the leg opposite 30 degrees. X root 3 is the leg opposite 60 degrees. You may also hear me refer to it as the shorter leg and the longer leg. The shorter leg is x, the longer leg is x root 3. And the hypotenuse is 2x. So again, this one has multiple ways of applying. Okay, the easiest way is, again, these are all 30, 60, 90 triangles. If you're given the leg opposite 30 degrees, it's the easiest application. Because what do you have to do to find the hypotenuse? Once you have this shorter leg, you can find all the other pieces. The hypotenuse is double that, so in this case 10. And the longer leg, or the side opposite 60 degrees, is going to be this length times root 3. Okay, so you can, again, apply those directly. It winds up being a real straightforward application. Okay, in addition to this, the next easiest one would be if they gave you the hypotenuse. So if they told you that the hypotenuse was, let's say, 12, what does that mean the shorter leg's going to be? Shorter leg will be half of that, so 6. And that means the longer leg will be 6 root 3. So once again, it just fulfills the patterns in those cases. Okay, next would be if you were given the side opposite 60 degrees, but it fit the same pattern. And so if you were given the length, let's say 10 root 3 for the side opposite 60 degrees, what does that mean the shorter leg is going to be? Shorter leg will just be 10, right? This fits the pattern of x root 3. And if the shorter leg is 10, what does that mean the hypotenuse is going to be? Hypotenuse is double that, so you get a length of 20. Okay. Now, just like with the other set, the 45, 45, 90, if I gave you a radical, 2 root 2, let's say, is the shorter leg, what does that mean the hypotenuse is going to be? double that or 4 root 2. And if the shorter leg is 2 root 2, in order to find the longer leg, we're going to take that value, 2 root 2, and we're going to multiply it by root 3. And so it's just a matter of simplifying. Again, 2 times 3, combine that product inside one radical. Okay, and so these, again, bless you, these would be what I would consider the easy applications of this, or the easier applications. Are there questions on any of these where I'm coming up with the numbers? Okay, I'm going through them quickly. Okay, the most challenging application comes when, just like with the 45, 45, 90, if I gave you the length of the side opposite the 60 degrees in this case, the one that has the radical pattern associated with it, and it was not in the form of the pattern. Okay. So again, the pattern that we're looking at is shorter leg x, hypotenuse double that, the longer leg x root 3. Okay. And so what we could think of this is the given length of 12 is equivalent to x root 3. If we were to solve this, we would have to divide by root 3. Dividing by root 3 requires rationalizing the denominator. And so really, to solve for x in this case, what you would need to do is, as you multiply across, root 3 times root 3 is just 3. It's very similar to what we did with the 45, 45, 90. Dividing by root 2 is equivalent to dividing by 2 and multiplying by root 2. Dividing by root 3 is equivalent to this, dividing by 3 and multiplying by root 3. So it's that very similar pattern. And so in order to solve for our x value, and x represents the leg opposite the 30-degree angle, all we need to do is take our given side, 12, divide by 3, multiply by root 3, and that's this x value. So 12 thirds is 4 root 3. So we found our shorter leg. Once we have our shorter leg, we can double that to get the hypotenuse. Double 4 root 3 gives us 8 root 3. Okay. So again, if I gave you the side opposite 30 degrees, and it was, let's say, 30, what does that mean the other two sides of this triangle are going to equal? The shorter leg will be what? 30 divided by 3, which is 10 root 3. And then the hypotenuse will be double that, 20 root 3. Again, the hardest thing that you would see probably on these would be if I gave you a number now that's not divisible by 3. So if I gave you something like 17 as the side of your, or the length of your longer leg, if that's the case, then the shorter leg can be identified by taking the longer leg, dividing by 3, multiplying by root 3. It's still an easy solution because it fits the same pattern. Divide by 3, multiply by root 3, and then just double this. When we double 17, we get 34 over 3 times root 3. So it still fits the pattern. It's still an easy calculation as long as you understand, just like with the other. You're going to first divide by 3, and then second, you'll multiply by root 3. All right, questions on this? Okay, so if you look at the sample problem 12 and 13 in your books. Sample problem 12 states, find the diagonal, length of the diagonal of a square whose perimeter is 20. And problem 13 says, find the altitude of an equilateral triangle if the perimeter is 21. So again, here is your altitude. Perimeter is 20. What does that mean each side length is? 5. And if each side is 5, what does that mean the hypotenuse or the diameter in this case, or the diagonal in this case would be? 5 root 2. And then in question 13, your equilateral triangle, if the perimeter is 21, what does that mean each side length is? If each length is 7, then when we form this 30, 60, 90 triangle, the side opposite the 30-degree angle will be 7/2, which means the longer leg will be 7/2 times root 3. And so 7 root 3 over 2 would be your answer for question 13. All right. What I'll do is I'll unlock the 5-3 material. You can get started on it if you want. You can also work through the 5-1, 5-2 additional worksheet that's just kind of, again, there to refresh your memories on the 5-1 and 5-2 material. If you have any questions, again, the 5-3 stuff won't be due until Friday, so you have plenty of time to work on it.